Hello, welcome to today's lesson on constructing ray diagrams for concave lenses. In this lesson, we will recap what we already know about concave lenses. We will then learn to construct ray diagrams for concave lenses. Previously, we've learnt about concave and convex lenses as well as real and virtual images. We've also learnt how to construct ray diagrams for real and virtual images for convex lenses. Carrying on from there, today we will learn about ray diagram for concave lenses. To begin, let's recap what a concave lens is and how it interacts with light. Concave lenses are also known as diverging lenses because they spread out light rays that are initially parallel. When parallel rays of light enter a concave lens, they diverge or spread out, as if they were coming from a single point behind the lens. This single point is known as the virtual focus. The term virtual focus is used because the rays of light only seem to originate from there. They don't actually pass through this point. In practical terms, these rays never converge on the opposite side of the lens, making the focus a point from which the light appears to be coming. An important characteristic of the image formed by a concave lens is that it is always virtual, upright, and smaller than the actual object, irrespective of the position of the object. Understanding this property simplifies the process of drawing ray diagrams, as the nature of the image is consistent. To locate the virtual image formed by a concave lens, we only need to follow the paths of two specific rays. The first is the ray that travels parallel to the principal axis of the lens. When this ray reaches the lens, it diverges outward as if it originated from the virtual focus behind the lens. The other is the ray that travels straight through the center of the lens. Unlike other rays, this one does not change direction as it passes through the lens. Let's use this information to construct a ray diagram. First, draw the horizontal line to represent the principal axis of the lens. Next, place the concave lens in the center of this line. Then, mark the virtual focus point, F, behind the lens on both sides, ensuring they are equidistant from the center. You should then represent the object, usually with an arrow, above the principal axis on the left side of the lens. From the top of the object, draw a ray parallel to the principal axis towards the lens. After passing through the lens, this ray should diverge in such a way that it appears to come from the virtual focus behind the lens. Use a dashed line to extend this ray backward to indicate the virtual path. Next, draw a ray from the top of the object, straight through the center of the lens without changing direct union. At this point, you should have two rays, one that diverges from the virtual focus and another that passes straight through the lens's center. To locate the virtual image, extend the diverging ray backward until it intersects with the ray that passes through the center of the lens. The intersection point on the same side as the object is where the virtual image forms. Finally, draw the virtual image at this point. The image will be upright and smaller compared to the original object. This completes the ray diagram for the concave lens. In today's lesson, we focused on constructing ray diagrams for concave lenses, also known as diverging lenses. We began by recapping that concave lenses spread out parallel light rays, making them appear as though they originate from virtual focus behind the lens. To construct a ray diagram, we first drew the principal axis and positioned the concave lens at the center. We marked the virtual focus points behind the lens and drew the object above the principal axis. By drawing a ray parallel to the principal axis diverges from the virtual focus, and another ray straight through the lens center, we combined these to locate the image. Through these steps, we effectively depicted the behavior of light through a concave lens and located the virtual image. Watch the rest of the GCSE physics course at Sophos Education.